Okay, thank you guys for being here. Thank everybody being here virtually. We appreciate it. Talking about sustainability and showing you guys a model for a truly climate positive data center today. I'm going to dive in quickly because we have a packed agenda, as you can see. I'm here with my collaborators, Lars Skaden from EcoDataCenter, Daniel Pope from Submer, and Jacob Bostrom from Green AI Cloud. And together, as a community, we've been able to put the pieces together to really do something that is truly climate positive. So we're going to talk about that. Why do we care about sustainability in the data center industry? Why do we care about it in the OCP community? Because hardware is, in order to do everything we need to do to capture the positive potential of data centers and technology everywhere, it demands a ton of hardware and a ton of energy. And so we have a responsibility to think about that and do it right, and do it differently than we've done it in the past. We're going to talk about circularity. It's one of the key strategic initiatives, obviously. But some stats first. So this scale of what we are trying to do is immense. Infrastructure Masons recently put out some data, 104 gigawatts of data center capacity, 7 million data centers. That number is growing. That number does not include the crypto space. Gartner expects 75% of enterprise data by 2025 to be generated at the edge. That's an immense amount of new infrastructure that's going to be required to support all of that data generation, analytics, and so forth. IDC, 175 zettabytes of data expected to be created by 2025. Immense scale. This one I find particularly interesting. 45% of available clean water is used by data centers. 45% of available clean water. We have to think about sustainability, guys. One car generates as much data as 3,000 people every hour, autonomous vehicle, and we're already at 1 billion 5G connections, right? So we just have to think about what is the consequence that goes along with the powerful potential we have in our fingertips. And candidly, we have to think about new approaches. We've done a really good job, especially in this community, but in the data center industry generally, on things like PUE, things like getting to renewables, things like offsetting our way out of our sins, but that is not sufficient. We have to continue the quest to renewables, but we have to do a lot more. And it is all about scope 3 and circularity. Couple of key stats. CDP will tell you that there is 6 times the amount of carbon in supply chain than there is in operating footprint on average with companies reporting into CDP. That number is a lot more for other people. I think Microsoft CDP numbers say it's 25 times. That's all because of the embodied carbon in IT equipment and in data centers, which we're going to talk about today. Jumping to the right side, very specifically, we've done a life cycle analysis on the carbon of OCP racks specifically. And 75% of it, in a very common deployment model, is tied to manufacturing. So we have to think about, in addition to renewables, in addition to PUE that tackles operating phase stuff, what are we doing to avoid emissions, to decarbonize the supply chain? And then it's not just IT, it's physical infrastructure, as we'll hear about from Lars today. And if you just look at the construction stats, construction accounts for 40% of global energy usage. That is all your scope 3. Everybody running a data center, that becomes your scope 3, right? You guys have seen probably the stats on cement and concrete. It's not pleasant. So circularity is essential. As I said, we have to keep doing everything we're doing to drive down operational phase energy. In the supply chain, where we can decarbonize, we absolutely must. We have to continue on the renewable side, as I said, but we have to think about circularity and scope 3. And what that means very tangibly is how are we creating regenerative models, whether that's recertified IT, which we'll talk about, whether that's heat recapture, whether that's water recapture. How are we creating data center models that are delivering positive environmental consequence and not negative? And we believe among us that there's a model at hand that we're already delivering on that we want to tell you about today. So with that, I'm going to set kind of the agenda here, which is everything from buildings to power to IT to heat to waste. All of this comes together, and it comes together in the most demanding workload environment, which Jacob will talk about from an AI perspective. We're not talking about kind of legacy environments, legacy workloads. We're talking about modern, powerful workloads that can be done in a climate positive way. So super excited to tell you about that, and I'm going to turn it over to Lars to kick us off on the first part of that, buildings and power and the platform.
Yeah, thank you, Ali, for that introduction. Well, in order for us to be here to present to you the most sustainable computing capacity there is in the world, we need to start from the very basic part, the foundation, and that's the data center. First of all, you need to find a location in where you are able to build an ecosystem. And thereafter, you need to consider, which we are trying to do, to apply full scope of greenhouse gas protocol. So, when we are designing, constructing, and installing our data center, as I said, we are trying to also consider the scope 3 in greenhouse gas protocol. That's the main challenge. We are building our core and shell in pure laminated wood. Laminated wood is by far the most sustainable solution there is, trying to avoid, as much as possible, avoid concrete and steel in the building. Concrete still counts for a big part of the global emission. I think it counts for still 8% of the global emissions on a yearly basis. So by avoiding that as a material, we have done a huge benefit for the environment. Then when we come to the technical installations, together with our strategic supplier, Schneider Electric, they provide us with a sustainability report so that we can see how much embedded carbon there is in their products. Not for all their products, they are not there yet, but they are on their way. But we have identified that the main challenge for our industry regarding to technical installations, that is the lithium-ion batteries. So far, we haven't found any better alternatives, so we need to charge that embedded emissions to our customer. But, of course, the third part is that we are operating all our data centers with purely renewable power. And that's great. You can't get anything else but renewable power where we're located. 75% hydro and 25% wind power. That's great. Because we all know that renewable power comes with 0 carbon. But that is not true. Because when you are applying scope 3 on renewable power, and that's been done by the national utility company Vattenfall in Sweden, they are applying a life cycle assignments on all their power production sites. And they can verify that hydropower in Sweden comes with 9 grams embedded emissions per kilowatt hour. And someone needs to take that bill. We do that. We take that bill and charge that to our customer. And wind power comes with 12 grams. And it's not strange because if you look at a hydro plant, it contains a lot of concrete. So even though that it's depreciated over 100 years, it's still 9 grams. And with the power mix we got, we can calculate our part of the embedded emissions. And on top of that, we need to add the PUE, of course. And on top of that, we also need to add any distribution losses. Because distribution losses still counts for, it's the 3rd largest consumer of power in Sweden. And someone needs to take that bill. We do that and charge that to our customer. But all that is mitigated by the way we are recapturing the heat. And we do that in 2 ways. First of all, we are injecting the heat into the municipality district heating system. Meaning that during the cold season in Sweden, because it could be really cold, then they can avoid using oil or gas, using our heat instead. And by doing that, we are avoiding certain emissions. But avoided emission is not accepted yet by greenhouse gas protocol. But we say that in our industry, we think it's important that we benefit from reusing the heat. Secondly, and this is the uniqueness in our solution, when the heat is not needed into the district heating system, because it's not always cold in Sweden, then we are producing pellets. And pellets contains of sawdust, pressure, and heat. And those are later on stored in huge bars and later on sold to houses and industries not connected to the district heating system. Their alternative would otherwise be to use oil burners. So now they are burning our pellets instead of oil. And by doing that, we are avoiding huge amount of emissions. And that is what we are summarizing to our customers. Being able to present a full, transparent sustainability calculations according to greenhouse gas protocol, scope 1, 2, and 3. Then it's separated for the avoided emissions so that we can provide to our customers how much embedded carbon and direct emissions we have had with our service delivery, but also how much emissions we have been avoiding with our solutions. This is an average over a year. Of course, this will vary or change over a seasonality due to PUE, et cetera, but this would be an average for us to deliver to our customer. So, back to you, Ali.
Thank you, Lars. I'm going to come back to this. You can see this number, 33 grams per kilowatt hour of carbon avoided with the EcoDataCenter model for a 1 gigawatt average typical facility. So we've touched on this. I'll go quickly. A huge part of the carbon tied to IT, when you just look at the IT equipment, is tied to that manufacturing phase. When you look at enabling a second life, and saying, okay, well, let's think about lifetimes in their aggregate, and you take that life cycle analysis and you build into it the next phase of the model, which is, okay, run it for one life and then cascade it into a second life and see if we can truly maximize it. The impact is very significant. So the impact of doing that gets you another about almost 25% for this particular deployment model of saved carbon. And just to put that in context, that would be equivalent to driving another 68% gain in PUE. So we must continue on the operating phase focus, but we're still, the next phase is this embodied carbon, and then we have much bigger ground to carry there, to go get there. So it's the next place we have to look. Could we enable a second life? We have enabled a second life. So you guys people can see on the floor outside here, the Sesame Integrated Rack Scale Solutions, which also tie to the other strategic initiative of OCP, which is integrated solutions and making OCP useful, usable, more acceptable, more accessible to the broader markets by doing the test, doing the integration, making it really easy. We're doing that in a way that enables kind of circular second life products that also deliver not only best-in-class TCO, but also sustainability. So putting that in context, I'm going to come back to Lars's chart. So here you see Lars's chart, same thing, 33 grams per kilowatt hour of carbon saved by the EcoDataCenter model. When we add in the IT equipment recertified to power that 1 gigawatt facility, you add a tremendous amount more, and you end up almost 4 times that, 113 grams per kilowatt hour saved. So you can see that the IT burden alone carries significant impact opportunity for all of us to think about, and that's obviously the piece that we do as ITRenew. But ultimately, there are workloads running on that, and there's more to this story. So I'm going to turn it over to Daniel to talk about the next part of circularity on the immersion front. So thank you, Daniel.
Thank you, Ali. Thank you very much. So Ali has been talking about challenges in the data center industry. Lars has shown us a completely different circular model with EcoDataCenter, which is super exciting. I'm going to talk about immersion cooling a little bit and the impact that it's going to have on the industry moving forward. Here are some challenging numbers again, I guess, but we're going to focus on the right-hand side. 98% of the energy consumed in a data center is converted into heat. We all know that. We've all walked around the data center. It's all very hot, right? So what if I told you that thanks to immersion cooling technology, we can actually capture that heat and put it to use, high-grade heat, reuse it in different environments, in different use cases that I'm going to talk about. And for those of you that haven't heard of immersion cooling, at this stage I think it's quite difficult, but it's essentially changing the medium that we use to cool electronics. Today we leverage air. Tomorrow we expect it to be a dielectric fluid, a non-toxic, and in our case even biodegradable fluid, which is cooling the IT equipment and any electronics. Why is single-phase going to be a key single-phase immersion cooling going to be a key technology down the road? First, because heat reuse is inevitable. There are government-driven regulations rolling out across the globe that are enforcing the use or the implementation of certain levels of heat reuse for the industry. Because we have to do it would be the second reason. It's incredible the amount of energy and water, as Ali mentioned, that we're wasting today in the industry. And it's our social responsibility, and we should own changing the industry moving forward. Third reason would be it's the first time that that we can capture high-grade temperatures in a fluid, and that we can capture and transfer all that energy that I was referring to for a heat reuse purpose. The main driver, like for everything, is going to be TCO. So why do we see now crypto miners transition into immersion cooling, single-phase immersion cooling? The main reason is, of course, TCO in the cooling infrastructure. We have been working very closely with the major utility companies, especially back in Europe, where they are all willing to build models where they can create new revenue streams for the data center industry. We have customers today that are receiving $40 per megawatt hour of high-grade heat delivered into district heating networks, which is a very exciting new revenue stream for the data center industry, probably more exciting than the real estate game behind it. And immersion is going to be, as I mentioned, the only technology that can capture that 90%, 98% of heat generated in the data center and transport it and reuse it. While as with air-based technologies, there are humongous losses that just don't make it very viable, to say the truth. So 3 use cases I'm going to talk about. Data center waste heat into district heating networks. LARS is already doing that, essentially. I've briefly referred to how the utility companies are willing to monetize and provide new exciting revenue streams there. The second use case is data center waste heat into neighboring industries around the data center. So when you don't have a district heating network, a symbiotic partnership with someone who is potentially around the neighborhood is a model that's working. There are already quite a few examples with fisheries, with farming, we have a customer warming swimming pools, et cetera, et cetera. And the third use case, which is an implementation more at the edge, also very exciting, is where you run compute in the same building that you're warming. So you're injecting the heat directly into the building, or potentially a neighboring residential park or business park, for example. So these are the 3 use cases that we're mostly seeing today, and feel free to reach out if you want to tap into any of those. And with that, I'm going to hand it to my colleague Jacob from Green AI Cloud.
Brilliant, thank you. Right, so I'm going to talk about sustainable AI. Let's see. Right, so with AI, you have a huge demand for power, a growing demand for power and compute, and this is really I think the ideal use case for what sort of to do with that surplus of power. You have the enormous processing power that is sort of that is required, but that in itself creates a bottleneck for how you can scale this. So in essence, we've created a software layer on top of this entire ecosystem. And I think this is a rather busy slide, but in essence, creating an AI model has a cost in kilowatts and megawatts, depending on how large it is. And using this model, which we have operational today, creating an AI model, it will tax the sort of environment with 8 to 10 tons of CO2 emissions. And that's equivalent to about 16 cars driven an entire year. So that's creating one model. And that's using 5 to 20 petaflops of compute, something like that. And or my cloud delivery, we've looked at ways to sort of harnessing all that excess heat, et cetera. And then connecting that to software, really. So you want to process your model, you want to create you want to do AI compute, but you also want to have, you want to know how much CO2 you're using while creating that model. So essentially, we're taking the kilowatt figures from LARS and this entire ecosystem and the embedded carbon in the manufacturing side, and then applying that kilowatt value to the model you're computing on. And then in essence, we can then, per model, per customer, per client, because we're a public reserved cloud, we can say that this particular model generated this X amount of CO2, or the avoidance of X amount of CO2, or the negative value of CO2 if we produce the pellets and offset oil and gas. Yeah, so in essence, this is what sort of ties it all together, like the circular reuse of hardware, the use of only renewable energy sources, the use of excess heat, pipelining that to nearby industry, and then connecting that to a hyperscale type performance delivery, because this delivery becomes the opposite of what we usually have in a data center. The more heat you generate, if you're sending that to industrial process and instead of using oil and gas, you'll increase the amount of negative CO2. You'll offset what you will otherwise be doing while sort of participating in that industrial process. Yeah, so that was me, in short.
Awesome. Thank you, guys.
Thank you.
So I'll just wrap up quickly here. I think what we wanted to do is show you guys that there are solutions today to have very immense, positive, powerful potential with technology and do some of the most rigorous and demanding workloads at the best possible performance. And it would be intuitive to think that those would come with a very negative carbon bill attached to them, but they don't have to. And what I would propose to the community is the next frontier is carbon accounting, carbon allocation models, data transparency. We must facilitate visibility into what's actually happening, and so that we can then incentivize the right behaviors and further define and coalesce the right solutions. And I think the OCP community is the perfect place to do that. We have the partners already at hand. We have a willingness. I'm thrilled that this is a strategic initiative this year. I'm thrilled that the word sustainability was used thousands of times yesterday across every single keynote and every conversation that we had. So I challenge everybody to take it to that next place on the carbon accounting side, adopt the solutions, come together and help us drive forward in a way that is not catastrophic to the climate as we do what we all hope to do. Thank you very much.